Welcome to our competency-based question series, designed chapter-wise to enhance your conceptual learning and understanding. Question 15. Resistances 10 ohm and R ohm are connected in the two gaps of a meter bridge. The null point is obtained at 30 centimeter on the meter scale from the zero end. What resistance must be connected in parallel to R so that the null point is shifted at the midpoint of the meter wire? We are having a meter bridge, and the scenario is something like this, that the resistance from the resistance box is 10 ohm and the unknown resistances are. We know the formula for the meter bridge, that R by X, it is equal to L upon 100 minus L, where X is the unknown resistance and R is the resistance from the meter bridge. In this case, L is given to us as 30 centimeter, that is the balancing length, when 10 ohm resistance is connected and R is the unknown resistance. So putting the values in the formula, we get, in place of R, we can write 10 ohm. This is the resistance from the resistance box, and X is the unknown resistance, that is R. 10 by R is equal to 30 upon 100 minus 30. And when we solve it out, 10 by R will be equal to 30 upon 70. R will become equal to 70 by 3 ohm. So this is the value of R we have obtained. Now we need to connect a resistor R1 in parallel to R such that this null point of the galvanometer, it shifts to the midpoint of the meter bridge, and midpoint of the meter bridge is 50 centimeter. So let R1 be the resistor connected in parallel to the resistance R, so that the null point becomes 50 centimeter, that is the midpoint of the meter bridge. So we can make the scenario like this, that this is a parallel resistor R1 and we need to find the value of this R1. Let the equivalent resistance of R1 and R be R equivalent. So we can replace this R1 and R parallel combination with an equivalent resistance R equivalent. Applying the formula for the meter bridge, we know 10 by R equivalent, that will be equal to L upon 100 minus L. And in this case, L is equal to 50 centimeter, that is the midpoint of the meter bridge. So this implies 10 upon R equivalent will be equal to 50 upon 100 minus 50 will be 50. That will be equal to 1. This implies R equivalent will be equal to 10 ohm. So the combination of R1 and R in parallel gives us 10 ohm. We can write 1 upon R equivalent, that is equal to 1 upon R plus 1 upon R1. This implies 1 upon 10, R equivalent is 10, is equal to 1 upon R, and value of R we have obtained as 70 by 3. So in place of this R, we can write 70 by 3 plus 1 upon R1. This will give us 1 upon 10 is equal to 3 by 70 plus 1 upon R1. When we solve this, 1 upon R1 will be equal to 1 upon 10 minus 3 upon 70, and that will be equal to 70 is the LCM, 7 minus 3 will be in the numerator. So 1 upon R1 will be equal to 4 by 70, and finally we can say R1, it is equal to 70 by 4 ohm. So that is the resistor that must be connected in parallel to given R so that the null point shifts to the midpoint. Option C is correct, that is 70 by 4 ohm. Thank you. Keep learning, keep practicing, keep excelling.